Hello, my name is Rahman Lefwich Jr., and this is my presentation for Data 625, the Unit 6 Network Graphs assignment. And today I'll be walking you through my security assessment of two employee messaging networks, Network 1 and 2, and I'll compare their structures, the security risks they pose, and why I rated them the way I did. First, we will be looking at Network 2. This dataset represents 50 employees and their messaging connections. Each line in this dataset is a relationship, and in the visualization, every circle is an employee, every line is a message path. I use a color scheme similar to Sophie Hickox's example, but with my own twist. I use cool greens for low-risk nodes and warm reds for high-risk between-risk nodes. Between-risk measures how often a node sits on the shortest path between others. So it's a good proxy for high value targets. And the network 2 structure is fairly dense and meshed together. The average employee has almost 4 connections, and there is no isolated nodes. A few users like Stealth, Spectre, Shadow, Viper, and Ghost show up as bright central hubs, but there are also a lot of cross-links between other employees. So what does this mean for a security standpoint? This means that the network is robust for availability. And one device goes down, messages can usually route around it because there are alternate paths. Even if a single node gets a malware attack and has to be taken offline, most of the network can still communicate. The flip side is that that is great for lateral movement. Once an attacker compromises one of the central users, the malware has plenty of paths to spread quickly. From a client's perspective, a recommendation I would implement is to treat the high between-risk hubs as tier 1 assets, stronger endpoint protections, tighter access controls, and closer monitoring. Now we will move on to Network 3. This dataset also has 50 employees, but the connections are very different. Here, the average employee has about 2 connections instead of 4, and the layout looks more like a hub and spoke cluster. In my visualization, I again use warm colors for high between-risk nodes. Two names jumped out immediately, Nebula and Starhawk. Their between-risk scores are dramatically higher than everyone else's, which means most paths run right through them. When I filter the dashboard using the relationship wildcloud for Nebula or Starhawk, almost the entire network lights up. This means that Network 3 is more fragile than Network 2. If Nebula or Starhawk go offline, the network can fragment into smaller pieces, and certain employees may no longer be able to reach each other at all. From a malware perspective, Network 3 is kind of two-edged. If malware starts on a peripheral node, the spread may be limited because there are fewer alternative paths. But if an attacker compromises Nebula or Starhawk, the blast radius is huge, and the organization loses both security and availability in one stroke. For this client, I recommend hardening those 2 core nodes aggressively, also by implementing multi-factor authentication, type permission sets, and continuous monitoring. Adding a few rooted links between the clusters so the whole network doesn't depend on just 1 or 2 super users connectively. To conclude the side-by-side comparisons for Network 2 and 3, both networks have the same number of employees, but their risk profiles aren't really comparable. Network 2 is dense and more resilient. It supports good message flow even if one node fails, but the same connectivity makes it easier for malware to move laterally if central users is compromised. But for Network 3, it is sparser and more brittle. It relies heavily on a couple of supernodes, such as Nebula and Starheart, for communication. That reduces everyday exposure, but creates massive single points of failure in every high impact if those nodes are breached. Network 2 needs strong segmentations and monitoring to manage spread, while Network 3 needs architectural change to reduce dependency on just one or two people. I use colors and filters similar to Sophie Hiscock's approach to highlight these risk nodes and to let the stakeholders quickly switch between networks to drill into their specific users. I would like to say thank you for watching, and this concludes my Unit 6 assignment.